All right, now we're going to take a look at our R22 fixed orifice system that's overcharged, and we'll use the same diagram, same operating pressures and temperatures. In our previous videos, we had and have used the 75-degree room air temperature, 95-degree outdoor air temperature, and we have 20 degrees of superheat. That's with a properly charged, properly operating system. As a quick review, all of our refrigerant is changing state throughout the coil here until it hits its design point in the coil, and from this point forward we're all vapor, and it's designed so that it picks up approximately 20 degrees of superheat before it goes back to the compressor to ensure that we have 100% vapor entering the compressor. Now here's what happens when it's overcharged. We have too much refrigerant in the system. So what happens is we have our solid column of liquid refrigerant, the pressure is reduced, we go into the saturation point, and all of this refrigerant is changing state throughout this the evaporator coil because of all the heat that it's absorbing from the indoor air. And remember that change of state and all that heat causes a tremendous amount. It takes a tremendous amount of energy to change the state of the refrigerant. So we still are changing state, and we're at saturation temperature and pressure. And what happens is the refrigerant, instead of being 100% vapor at this point and picking up superheat as it goes back to the compressor, with too much refrigerant, it just continues to change state, and it may be 100% vapor before it hits the compressor, and instead of having 20 degrees of design superheat, you might have 10. Or if it's a little bit more overcharged, it doesn't turn into vapor until just before the compressor, and then we have 5 degrees of superheat. And then if it's really overcharged, you can have 0 degrees superheat. Now remember that our superheat is our gauge pressure, which we're picturing right in the middle of this evaporator coil. We convert that to saturation temperature, and then we subtract the temperature that we measure this line set at right here at the condensing unit. So if we are measuring our saturation temperature at, let's say, 40 degrees in the middle of the coil, that's how we convert it from our low side pressure gauge, and we are measuring 60 degrees at the condensing unit, we know that we have our 20 degrees of superheat. But when we're measuring that 40 degrees at the center of the coil and it's overcharged, this is saturated refrigerant is 40 degrees. If we still have saturated refrigerant at this point where we're measuring at the line set, if we're still flashing over from liquid to vapor, the temperature of the line here at the condensing unit is going to be 40 degrees as well. So that's our indicator of no superheat, because it's 40 degrees saturation temperature minus the physical temperature is going to be 0 degrees Fahrenheit. Now, how does the system get overcharged? That happens when you have a technician that doesn't understand what you're learning here about superheat and proper charging techniques, and they're going by rules of thumb or don't even understand what they're doing to begin with. The other thing to note is, unlike an undercharged system where you can add refrigerant a little at a time, the best way to take care of an overcharged system is to reclaim all the refrigerant properly into a clean reclaim jug. Then you evacuate the system to 500 microns and make sure there's no leaks, and then you weigh the refrigerant back into the system, and the amount of refrigerant that you weigh back in is noted on the data plate, and then you're going to be very close to your proper superheat, you just have to account for however long the line sets are. There are charts that can help you figure out how many ounces more you need, and usually you're close enough with your superheat that you can just add just a touch more refrigerant and get it dialed in right on the money. All right, so if the more overcharged the system is, the less superheat that you are going to be measuring. Remember, a high system charge results in low superheat and can result in no superheat. Okay. All right, so that is it with our fixed orifice R22 system overcharged. If you have any questions, shoot me an email or send me a private message in our online classroom, and we will cover next overcharge and undercharge system with a TXV device.